Hey guys, welcome back to this lecture run as ECS container. In this lecture, we will learn how we can run the Prometheus service as an ECS container and we'll see how we'll access them. So there are different steps which we will perform, and before actually jumping onto the demo for the Prometheus service deployment in ECS container, we need to make sure that we do have the running ECS cluster and the other components that we need to run Prometheus in the ECS container. So I'll quickly take you to the demo. Okay, so here on the screen you can see I'm in the ECS console right now in my AWS account, and the very first thing we will do, we will create a new ECS cluster. So I'll do it quickly so that we do not spend much time on creating these resources. I'll use this EC2 Linux plus networking template so that it creates an ASD group for me, which will manage my ECS instance. Cluster name I'll give as Prometheus demo cluster, let's say. Okay, it will be on demand instance. I'll make it like I'll go to t2 dot small, or let's say medium. Key pair I'll not use any. VPC I'll use the existing one. Subnet I will use the existing, although you can create the new networking here as well. Okay, auto scaling group I'll use the last one which we have created in the last lecture. When you create the ECS cluster very first time, it asks you to create a new role here, so it shows this create new role, so you can use this as well. So once you'll create it, it will create a new role for you. Okay, let us create it here. Let the resources created. So these are the resources that it is creating. As you can see, this is the instance type. AMI ID will be this. It will be VPC subnet, VPC availability zone, security group, launch configuration, auto scaling group. Okay, now my cluster is ready. Let us go to the cluster now. Okay, now it's time we create a task definition so that we can run a task on it. Okay, so let us go to task definition and create a new one here. I'll use the launch type as EC2 because I want to run my workload on my EC2 machine behind the cluster. Task definition will be, let's say, Prometheus demo definition. Task role I'll use the existing which I've created for this. So this role is basically which gives your container permission to access the other AWS resource. Suppose your container wants to access S3, right? So in that case, this particular role which you are assigning to task should have the S3 permission. Then only your container will be able to use the role. In the network mode, I'll be using the bridge network task execution role. You can create a new, or you can use the existing one. I'll go with the existing one. Okay, task memory I can give 1024, so it's always best practice to use the resource limits on the task. Now it's time to create a container. Okay, great. So I'll create the container here, Prometheus, and in the image I'll give prom/Prometheus latest. Okay, now as it is a public repository, we do not need the authentication. If you want, you can limit the memory for your container. So it's always the best practice when you're running multiple containers inside a task, then you should limit the container resources as well. Port mapping I'll do 9090. Okay, next there are other attributes as well which you can use in your typical architecture. Health check you can set up the environment variables, entry point or command which should run while creating the container, right? You can set up the network settings, you can create the host name for that, right? So that will be attached to your container, or you can create mount point, storage, logging, security. You can, if you want to run your container with privileged user like root or any other user, you can specify here. Resource limit, here you can specify the upper limits, right? U limit, lower limit. Docker label you can also give. So but in this demo we do not need any of this, so I'll just add it here, and here I'll go down and I'll create the definition here. Okay, let the definition created. It is created now. You can see this is my task role. Okay, compatibility it is showing as is external and EC2 execution role. Okay, this is fine. Now let us go back to our cluster and create a task here. In the task I will run a new task and I'll use the definition which I've created, Prometheus demo definition. what revision is 1, and I'll give the rest as default. I'm not using any placement template or any other tag configuration, so I'll keep it as default and I'll run the task. Okay, so it is in pending state. Let it convert to running here. Okay, great. That's now it is running here. So now it's time we validate whether this my container is actually running or not. So as you remember, we have mapped the port 9090 on the host. So what we can do, we can use the host port to access the Prometheus or this container. So let me go to the ECS instance for this, which is running behind it. Okay, I will pick the public IP from this and I'll see on 9090 port whether Prometheus is coming up or not. Okay, that's great. So it has loaded now. Here you can see Prometheus console, and in the build information you can see your build version, go version, and other details. Okay, so now we have learned how to run Prometheus in ECS container. Now it's time to see how we can map the container volume to the host volume so that we can modify the container configuration, or say Prometheus configuration file, without going inside the container. So let us do it. Let us go to the task definition here, and in the task definition we will create a new revision, and now we will work on the volume mount. Okay, great. So first of all, I'll create a new volume here on the task. I'll give it a name as configuration, and I'll make it like mnt prometheus.yaml. So this is the path on my ECS instance where my Prometheus configuration file is. Okay, now I'll go inside my container. Now I need to mount that particular volume inside my container. So here in the mount points, I'll select the configuration, and now I will give the container path where my Prometheus configuration file is inside the container. Okay, I've given the path here. I'll update it and I'll create it now. Okay, so new revision 7 is created here. Okay, now it's time we run a task from this task definition. I'll run a new task here. I'll select EC2, and here I'll select the latest revision which we have created for this, and then I'll run the task. Guys, please do not get confused with the revision number, because these videos are recorded intermittently, so that's why those names are already existing and the revisions get sequentially increased. That's why we are seeing some gaps in the revision numbers here as well. Okay, so now it's time we run the task here. Okay, the task has started now. Let us wait for it to complete. Okay, great. So now we can see it is running here. Now let us see, the port number is 9090 again, and this is the external link. So let us go on to this link and let's see if we can access it. Okay, we can access the Prometheus here. Let it load. Now let us verify whether we are actually able to update the configuration from ECS instance. So let us go to the configuration here, and here we are seeing the job name as Prometheus. Okay, now it's time we update this configuration file from ECS instance and then see whether it is taking effect or not. So for that, let us go to ECS instance. Let us connect to this server using session manager. Now switch to user. Now I'll go to the path where my Prometheus configuration file is inside my ECS instance. So I'll go inside MNT. I can see the Prometheus YAML file here. I'll update this file to show the name as Prometheus1 in the job name. So we are just making these changes to validate whether changes are visible over the Prometheus console or not. Okay, so I've updated the Prometheus YAML file here. Now it's time I restart my container so that I can, or the changes can be reflected over the console. So I'll stop and create a new task from the same definition. Okay, I'll run the task here, it is in pending state right now. Okay, it has changed to running now. Let us go to the external link and let's see if it is showing the changes. If I'll go to the configuration now, okay, great, the changes are visible here. We can see the file is updated now. So this is how we mount the container path to the wall, to the host path, and we can make the data persistent. So suppose your container goes out sometime, or suppose the tsdb data where your container is storing the time series data, you have not mounted it on the ECS instance and your container wipes out, then in that case all the data inside the tsdb database will be wiped out. So to make the data persistent, you need to use the mount volume or mount points here. Okay, so we have covered it now, so I'll take you to the next lecture. Thank you.